Algebra 2, Lesson 120. What a milestone, you guys. We are rolling through this book. Age word problems is our topic today. They have a very specific style. You'll see in a minute when I read you one, but they sound like a very specific type of problem. They're all quite similar. There's not a lot of confusion about, oh, how does this work again? And there's a very specific format for working them through. And the key is in how we set up the variables. So let's dive in and try one. Example 120.1. Let's see how many there are. There are 3. Here's the way they sound. I'm just going to read it through. A man is 13. Oh, sorry. Oh, I have to yawn. Oh, I'm sorry. How did I make you yawn too? A man is 13 times as old as his son. In 10 years, he will be 3 times as old as his son will be. How old are they now? Okay, so this is how they always work. There are 2 people whose ages are being compared now and then either in the future or in the past. Some combination of those time elements. Past, present, future. So, what we do when we set them up, we've got a man and we've got his son, and in this particular one, the 2 time frames are now. What's the other one? In 10 years. Okay, so in the columns, I'm writing the time frames, all right? And that will change from problem to problem. But as you'll see, as long as we put them in order, past, present, and future, it'll all make sense. Now, for the present, we set up the variables. The man now, the son now. In 10 years, it'll be the man's age now plus 10. The son's age now, plus 10. Now we've got our variables set. We know exactly what they should be, and we can take these and write the equations. So let me go back to the book. A man is 13 times as old as his son. Okay, so the man's age now is greater than the son's age now. But if we multiply the son by 13, then they'll be equal. Okay? It's that old trick of writing an inequality first and then fixing it and making it an equation. That keeps us from making those mistakes that the man's 13 times older, so we want to multiply the man by 13. No, that makes them less equal. We want to make them more equal, so we multiply the son. Okay, in 10 years, he will be 3 times as old as his son. So, the man in 10 years will again be older than his son in 10 years. But this time, instead of 13 times older, he's only going to be 3 times older. So I put the 3 in, and I put parentheses around the son's age because I want to preserve the distribution, right? Okay, so now they're equal. Okay, so now we are ready to solve this as a system of equations. I can see that if we substitute this in here, we're going to be okay, right? So let's do that. This is A, this is B. We're going to substitute A into B. This goes in here, right? So 13 Sn plus 10 equals, and then let's distribute 3Sn plus 30. All right, I'm going to subtract. Now we're just algebraizing, right? Minus 10, minus 10. Okay, that's gone, that's gone. 10 Sn equals 20. Yay, John. So the son's age now equals 10. Let's look and see what the book wants us to find. How old are they both now? So, I'm sorry, not 10. 2, making it hard. And so the man's age now is 13 times 2, which equals 26. And those are the correct ages, right? Yes, 2 and 26. Yay. So these are my answers. There's the first example. This chart helps us organize out how our variables work, and then we do this basic kind of equation writing and then solving. All right, the next one is going to get a little harder only because of fractions. I can hear you gnashing your teeth. Those darn fractions driving us crazy. Example 120.2. I'm just going to read it and then we'll make the chart and then we'll write the equations. 5 years ago, Brenda, excuse me, I'm yawning again. Brenda was 4/5 as old as Leighton. 10 years from now, she will be 7/8 as old as Leighton. How old is each now? All right. Brenda, Leighton. You can take the shortcut of just using B and L if you want. Whenever we're doing charts like this, do what makes sense to you. Substitute whatever works. Okay. I wrote this in a really weird way. Okay, I made 3 charts now because we've got 5 years ago. Make these bigger. And then we've got now. And then we've got 10 years. If you want, you can write -5 and plus 10, something like that, to help you keep these titles short. But we know that now we're going to have Brenda now and Leighton now. This is what we're solving for. These are not going to be in the equation because we don't have any information about how old they are now. This is what we're trying to find. But Bn minus 5, Ln minus 5, Bn plus 10, Ln plus 10. These are the 2 columns we're going to use to set up our equations because these are the 2 time frames that we get the information about. 5 years ago, Brenda was 4/5 as old as Leighton. Okay, so 5 years ago, Brenda's age was less than Leighton's age. And that was, she was less. So this is where it gets really confusing because we're going to multiply by a fraction that's going to make the number smaller because it's 4/5, okay? So if I multiply this number by 4/5, it's actually going to make it smaller, and that's what I want because this is the greater side now. If I multiply her by 4/5, then I'm going to make this number even smaller, and the inequality is going to become even greater. So I want to multiply him by 4/5, even though normally when we multiply, we think that's making it bigger, but we're multiplying by a fraction that's less than 1, so this number is going to get smaller. That's confusing. Take a second and let your brain wrap itself around that, right? We're making this number smaller when we multiply by 4/5, so now we can say they're equal. Whew. Okay, we're going to do it again. In 10 years from now, she will be 7/8 as old as him. Okay, so 10 years from now, she's still going to be younger than him, but this time the fraction is smaller. But it's still less than 1, so we're going to multiply this, the greater side, by the fraction less than 1. That'll make this side smaller, and that'll make these guys equal. All right? Whew, that's kind of a haul, isn't it? And look at these disgustingly ugly equations we have. Yikes. That's what's making this one harder. What I propose we do is get rid of the denominators and we'll talk about how to do that in just a minute. And then 2 will rearrange to the form of bn plus ln equals plain number. And these will probably have numeric coefficients, but then we'll get them both into that format. And then our third step will be to eliminate. Okay? That's the general process we're going to follow, and we'll walk through it and talk about it together. All right, this is an equation. So if I multiply both sides of the equation by 5, that will eliminate this. This, I can do it like that. I could have just written a 5 by each term individually. My brain just wanted to do it that way, I guess because there's parentheses over here. And then we'll multiply this side by 5. This 5 cancels against that. I have to distribute this 5, and I have to distribute that 4. So I'm going to go and rework some more on, I'm going to bring it down here. So we'll have 5bn minus 25 equals 4ln minus 20. Okay? I want to get them into this form, so I'm going to rearrange now. So I'm going to subtract the 4ln and bring it over here. And I'm going to add 25 to both sides. Okay? So I'm rearranging it to get into this shape. So now I've got 5bn, and I'm fine with the 5 coefficient, minus 4ln, that cancels, equals positive 5. Okay, so there is my new a. That's the one I want to use for my elimination. All right, now I have to do the same thing to this guy. Denominator is 8. I'm going to blow that up. I'm going to multiply this side by 8. That is going to cancel, and then I'll have to distribute the 7. Last time I put parentheses around it, so I'll do that again. If I multiply this side by 8, I have to multiply this side by 8. There's nothing to blow up, so that'll just be a straight distribution. All right, so now I'm going to work on b down here, because I want to have space up here to do my elimination. So now I'm going to distribute as I recopy. 8bn plus 80 equals 7ln plus 70. Okay, subtract the 7ln to get it over here, because that's the shape I want, and then I'll subtract the 80 for the same reason. So now I have 8bn minus 7ln, cancel, equals minus 10. All right, I like it. So now this is my new b. That's the one I want to use. I'm just going to recopy it up here. And then I'm going to be ready to eliminate. All right, 8bn minus 7ln equals minus 10. All right, we're back in business, you guys. So now we have an option as to how we eliminate these. We can either take down the bn's or the ln's. Either way is fine. Let's do this one. Let's multiply this by 7 and this one by minus 4. Okay? That'll get these both to 28. This one will be negative. This one will be positive. And that should be good. All right, so now I'm going to multiply. I'm going to draw a line here just so you can see that I'm doing that. 35bn minus 28ln equals 35. And now I multiply by minus 4. Minus 32bn plus 28ln equals positive 40. Okay? Adding these, 3bn, oh, by ln, you worked, equals 75. Oh my gosh. 3bn equals use any of our equations to solve for ln. I'll use this one, A. This is correct, PS. Just double check. Bn equals 25, yes. This is correct. And now I'm going to use this one, which is that, and I'm going to use all of this space. I'm going to ignore that line. 5 times 25 minus 4ln equals 5. 5 times 25 is 125 minus 4ln equals 5. Now I'm going to switch around. I want to bring the number over here, and I want to push the ln's over to this side. So I'm going to add 4ln to both sides, and I'm going to subtract 5 from both sides. I don't have room to write all that out, but this will be 125 minus 5 equals 4ln, and that gives me 120 equals 4ln. Divide by 4. Let's see if I can do this without writing the answer. And I get ln equals 30. That's the right answer. Yay. So here's my final answer. Okay? So, what did we learn in this one? We learned that sometimes we get the information from only the past and the future, but we go ahead and just set them all up. Notice how past, present, future. And then we learned that we can use fractions, and they're tricky because when you multiply by a fraction, you're actually making the number smaller, not bigger. So we have to factor that into our thinking here. And then we learned how to blow up the denominators, and then we rearranged, and then we eliminated. That was a lot. Just think of all the different steps of learning that are represented in this problem. Okay, ready? One more. Example 120.3. 30 years ago, Barbie was 1 year older than twice Mary's age then. 20 years ago, she was 4/5 as old as Barbie was then. How old is each one now? Okay, so this one has 30 years ago, 20 years ago, and now. So we've got Barbie, and we've got Mary. Did you guys know I'm the exact same age as Barbie, the actual Barbie? Yep, it's true, 1959. Okay, so I've got 3 columns. 30 years ago, 20 years ago, now. Again, I keep them in order because that just helps keep my thinking straight. I don't need anything in the future because the problem doesn't tell us about the future. All right, we know that now it's going to be Mary now. And so this would be Barbie now minus 30, Barbie now minus 20, Mary now minus 30, Mary now minus 20. Okay, we're ready for the equations. 30 years ago, Barbie was 1 year older than twice Mary's age then. So Barbie's the older one. She was 1 year older than twice Mary's age. So if we double Mary's age and add 1, this is 30 years ago. So this should be minus 30, and this should be minus 30, and then I put parentheses around it, right? 30 years ago, Barbie is older than Mary. That's her age then. She's 1 year older than twice Mary's age. So now we've got an equal sign. I'm going to rewrite that because that's really messy. Bn minus 30, Barbie's age 30 years ago. She's twice Mary's age, plus 1 more year. Okay, so this is our A. No fractions in this one to fix, so that makes me happy. I'm going to leave myself a little room to fix that though, because I know I'm going to have to rearrange. And now what about 20 years ago? 20 years ago, Mary was 4/5 as old as Barbie was then. Okay, so Mary was 4/5, so that means she was younger. That's minus 20. I did it again, didn't I? Okay, so 20 years ago, Mary was 4/5 as old as Barbie was then. So this is like the last one. If we multiply this by 4/5, then that makes her age smaller, and that will make them equal. Okay? So let's just fix this one as long as we're thinking about it. We're going to want to multiply this one by 5 to blow up the denominator, and then this also by 5. This one cancels. We'll distribute the 4. This one distribute the 5. So we will get 5mn minus 100 equals 4bn minus 80. Okay? And then once again, we're following the same steps that we did last time. We blow up the denominators, we rearrange them to get them ready to eliminate. So this isn't quite ready. We're going to want to subtract the 4bn, and I kind of want that to be first, because we've been talking about Barbie first and then Mary all the way along. So I want to make her first, and then we'll add the 100. So this is going to be minus 4bn plus 5mn equals 20. All right, good. I like that so far. This is my cute version of B. Now let's see if we can fix A. Look, I used up all my space with those distribution lines. What? Bn minus 30 equals 2mn minus 60 plus 1. Okay, I'm going to kick the numbers this way. I'm going to add 30. And then I'm going to bring the mn this way. Okay, cancel, cancel. So now I've got, this is my A version. I've got bn minus 2mn, right? So there's that and there's that. That's the one I brought across. And then this is going to be minus 60 plus 30 gives me minus 30. Plus 1 is minus 29. So far, so good. I'm just looking at my numbers here. I think this is pretty easy. Let's just multiply. I'm just looking at John's numbers compared to our numbers. Yes, that's the same. Okay, perfect. We're good. John's got this equation as this one. Every one of these terms has a different sign. That just tells me he swam things in the opposite direction. But as long as all the minus signs are exactly opposite, that means we have the same equation. So I'm happy with that. I would like to multiply this equation by 4 so that then the bn's will cancel. So this one stays the same. This becomes 4bn minus 8bn equals 29 times, okay, well, let's do this one in our heads. I'm not going to multiply it out. If this was 30, 4 times 30 would be 120. But this is 1 less, so it's 4 less, so it's 116. Okay? I'm going to squiggle this out now so that I compare these other two and my brain won't get confused. The bn's cancel. Minus 3bn equals 20 from that, that would be minus 96, right? Yes. Divide both sides by minus 3. And I see that bn equals 32. Barbie's 32. Let's see if John agrees. John. Okay, I am wrong. This is not bn. See, my bn's cancel. I accidentally wrote a bn here too and I got confused. This is actually my mn, right? So this is Mary, who's 32. Does that make sense? I just copied it wrong here and then I confused myself. But I did cancel the bn's, so that's right. So this is Mary. Okay, caught that little mistake. And now, what about Barbie? What am I talking about? It's Mary and Barbie. So now we pick any equation that we like, and we plug in. I'm going to choose this one. I'm going to use this as my space to do it. I'm going to ignore that too. And I'm going to say bn minus 30 equals 2 times 32 minus 30 plus 1. I'm using this, the original equation, right there. Okay? So now I can simplify all of this to bn minus 30 equals, okay, 32 minus 30 is 2. 2 times 2 is 4, plus 1 more is 5. Now if I add 30 to both sides, I'll get that Brenda now equals 35. And that's the correct answer. Okay? Woo! This one is hard. Look at all of that work, you guys. It's a lot of calculation. It's a lot of fixing. We followed our same 3 steps. Let's flip and show them again. We blew up our denominators. In that third problem, we only had one equation with denominators, but that's okay. We blew it up. Let me straighten you. We blew it up, then we rearranged it to get it into this format, which we think of as the elimination format, right? Variable 1, variable 2 equals number. Variable 1, variable 2 equals number. These can be pluses or minuses. It's just that we're adding and subtracting these two on the left side, and then we've got our plain number terms over here on the right. Then we look down, right, and we decide which one we want to eliminate. That's why it's important that we write them in the matching format. And then we go ahead with our elimination. Okay? And then we showed here that when you blow up the denominators, you cancel on the side with the denominator, and then the other side has a new distribution. This one also has a distribution because you blow up the denominator, but the numerator still stays. I feel like I'm saying too many words now. That's the end of lesson 120. Yay! We're almost done, you guys.